Thank you. I should admit that this is by far the most diverse audience I have to speak in my life. I'll try to keep it broad and generally interesting. So what I work with is cellulose, or I worked quite a lot in my career. And this is a special kind of cellulose that comes from algae. And the title of my presentation today is Cladophorus cellulose from environmental problem to high-tech products. Cellulose is an enormously important material for the industries. It is the most abundant polymer on Earth. It comes from, the one that is used in industries comes mainly from land plants. But as you have heard earlier today, there is also bacteria that produce cellulose. But these two are not the only ones that can produce cellulose. There are green algae that are capable of making cellulose, fungi, and then there is even some marine animals capable of producing algae and cellulose. And cellulose is a hierarchical material. It has a lot of different levels of organization. And the one that comes from green algae has a very special properties compared to all the other kind of cellulose. It's at least very different from the one that's used in pulp and paper industry. Why algae? Well, there is a special interest in green algae because they are usually used in a very negative context. They are mentioned a lot related to environmental problems we have, which are caused by human activity. And this is a global environmental problem, which is common not only for Scandinavia, the Baltic region, but also for the Great Lakes in the United States and Australia and Asia. And alarm reports are very common from all over the world. And the seasonal algae bloomings, they have two aspects to it. There is an purely ecological aspect to it, and then there is a socio-economic aspect. And the problems that are related to this proliferation of algae is that they displace other aquatic lives. They reduce the density of fish in the waters. They can cause runoff of oxygen at the seabed. The algae themselves are not toxic, but when they start to decay, as you see on the shores, they are a very good source for all the different kind of pathogenous bacteria to proliferate. And obviously, no one would like their kids to be swimming at the seashores full with pathogens. These algae increase the fouling of pumps. They are very hard to manage. They take a lot of resources to remove. And then they depress the property price along the shoreline. So there is a very big demand from the community to address the issue of this blooming algae. But yet there is no industrial use for this algae, which could put an incentive to really removing them. Otherwise, this remains as a problem of the communities, and volunteer work is usually not enough to tackle the problem. So what we have tried to do throughout the years is to find some industrial applications for this algae, which could trigger the interest in removing the algae and cleaning the shores and keeping the seashores clean. Well, 5% of there are applications, and one of the applications is to use the seaweed as fish feed. So 5% of fish they are herbivorous. That is, they feed on plants, and 90% of all these fish, they're in the tropical countries. So in the Southeast Asia, actually, there are small farms where they actually harvest the algae and feed the fish for different industrial applications, and in particular the milkfish. But our interest in this algae was more of what we can extract from it. And then one valuable material that one can extract is cellulose, because the cellulose content in this green algae is comparable to that of wood. And the structure of the cellulose is very special. So the cellulose is extremely highly crystalline. It has a very unique nanofibrous structure. And the algae themselves, they are an unexploited renewable source of this nanocellulose, which exists in the nature intact. But we so far failed to use it. Some of the applications of this cellulose. This is a group in United States who tried to use the cellulose from this algae to reinforce construction materials. So they mix it with polyurethane foams to improve the mechanical properties, to control color, to make it more biodegradable, and to decrease the cost. And yeah, what their results have shown that this is a very good reinforcement material for this kind of construction foams. One of the applications, one of the earliest applications I have worked with this cellulose was to use it in pharmaceutics. So the ordinary cellulose that comes from the land plants, it usually has a very low surface area. And if you try to load liquid drugs into this kind of cellulose material, the liquid drug, in this case nicotine, it would be located in the voids between the particles. But that would lead to the oxidation and degradation of nicotine. But when we loaded nicotine in the porous structure of this algae cellulose, the nicotine was intact because it was fully encapsulated in the particles inside, so the oxygen could not penetrate. And this was one of the early applications for this material in which we felt that there could be a high-value product that could come out of this. And this work was done actually in Pharmacia in Helsingborg, later Pfizer, and then they filed some patent, and yeah,